afternoon, everyone. This is Kim Reiki with the U.S. Army Corps of Engineers at headquarters, and I'm standing in as your host today for Eric Mucklow. The webinar is being recorded and will be uploaded to our video channel that can be accessed from the Sustainability and Energy website. The website can be accessed through the MRSI link at the bottom right-hand corner of your screen. If you'd like to receive learning units or CEUs for today's presentation, they're available by filling out a quiz after a block of 5 webinars and returning those quizzes along with your AIA number to the email address on the screen. Presenting today, we have Mr. Van Woods and Mr. Logan Wallace. Van is the BIM Innovation Program Manager for the U.S. Army Corps of Engineers Seattle District. He's responsible for the strategic BIM initiatives, R&D, and innovation incubation within the production environment on high priority BIM capabilities. Logan is a senior cost engineer also with the U.S. Army Corps of Engineers Seattle District. He's responsible for NWS planning and construction estimates for a variety of MILCON and civil works projects. Also, he is currently the cost engineering community of practice technical expert for integration of cost engineering with BIM workflows. The presentation today will be covering model-based quantity takeoff for cost estimating, focusing on background and principles. Performing quantity takeoffs from BIM has the potential of reducing the amount of manual effort and errors in the current process that requires counting and measuring by hand from construction document drawings. In addition to reducing manual effort and errors, it also has the potential of speeding up the iterative process. If quantity data were more accessible to cost estimators, designers, and other stakeholders at earlier project stages and more frequently available than just at major milestones, there would be greater opportunities for improved decision-making and trade-off analysis. This webinar will cover the principles of model-based quantification, describe the reasons for the importance of information quality, not just drawing quality, illustrate some of the current and future processes and their challenges and opportunities, as well as give some suggestions on how to get started and contribute to emerging best practices. We do have the question and answer area open for the whole presentation today, so if you think of any questions during the presentation, go ahead and type in the questions. And once Dan and Logan are finished with the presentation, I'll go ahead and read the questions out loud and they can answer them from there. So I'll go ahead and pass the mic over to Dan and Logan so they can start the presentation whenever.
So Kim, can you hear me?
Yep, and that looks great. I can see the presentation there.
I'm having some problems hearing here. Okay, I will assume that that you can hear me here. Sorry, our tests seem to work out just fine, but never fails. So when we go to give a demo, everything can seem to go south. So here we go. Thanks everybody for attending today. Really appreciate your coming to the discussion. Today we're going to be covering, I'm Van Woods, just to introduce myself. Kim already mentioned my title and the types of things I do, but today I'll be covering the first 2 bullets and the last bullet, and Logan will be giving some demonstrations on how current methods and model-based methods operate. So I will be touching on how quantity takeoffs could be applied utilizing a BIM workflow into MCASES, which is the Corps of Engineers standard cost estimating system, also referred to as M2. And in the second bullet, I think what we're really trying to stress in this that I think has a lot of relevance to the sustainability community of practice is this is not just about getting information to feed only into MKCs. It's really kind of our first step in the BIM community of practice of really focusing on the I in BIM, or the information, and we'll illustrate some of those examples. And then Logan, as I mentioned, will cover the some of the existing workflows and some of the model-based workflows, and I will end with an initiative that is ongoing, and then we'll end with question and answer. So what we're talking about today is essentially integrating designers and cost engineers more closely in the workflow. Clearly, there's information that's exchanged already through drawings and other manual methods, and what we're trying to do is to look at how to optimize that workflow and to increase the information exchange, but also the understanding and the communication between both parties. The real thing to stress here is that quantity takeoff is a separate activity. We're not discussing the idea that some take, which is to do model-based estimating, where you would put costs into BIM directly and then just produce a report from that, summarizing costs. We are focusing on M2 as the end state, and then integrating the primary authoring tool for designers, as you see at the bottom there, to then pass information to a quantity takeoff process where the cost engineer would then pick it up and then carry it through the estimating process. And there would be some iterations back with designers, and we would also expect BIM managers to be involved in making sure that tools and processes were optimized on the authoring and that the handoffs to estimators worked out correctly. And I should have shown in this slide also that there's a review process where the person performing the takeoff and the estimate is back checked by either a cost section chief or another cost engineer, so that the QA/QC process is also relevant. So when we're talking about quantity takeoffs as a separate kind of activity, these are the types of things we would envision needing to happen in that stage of a process. So again, when we start at the beginning and look at the authoring content in our design process, we perform things like the project execution plan and M3 for the minimum modeling matrix to manage the process. And all of those on the left should be fairly familiar to at least the BIM audience in the crowd. And for the estimating side, these would represent the typical estimating activities that will occur in the absence of a BIM workflow. The quantity takeoff is attempting to try to streamline some of the things that are either done manually or done with automation, but are still requiring a manual component to them. And we'll go through in the next section when Logan demonstrates some of these ideas, what we specifically mean by these. These aren't meant to be a sequential series of steps by any means. It's just to highlight that there are 7 kind of key areas that we're targeting. And there's a real emphasis on QA/QC and iterations, because the idea of being able to trust the data is paramount for cost engineers. It's kind of built into their regulations that they're responsible for verifying quantities. And then also the iteration aspect, I think we see as being a key feature of this process that will help speed up the process significantly with features such as change detection and things like that. And really, this is what I was alluding to earlier, this is a lot more than takeoff for estimating purposes. This is really about information management. And if you think about BIM as a database, and you think about some of these other downstream activities as also having ways of representing and storing data, this is really trying to determine how we can get from one to the other, while ensuring that the accuracy is maintained, and that there's no implied understanding of what the values are that are coming out. So, for example, probably applicable to this audience is things like lead analysis and documentation and life cycle cost analysis. We've done some initial examples where this is probably familiar to any of those that have done lead documentation, but there's some very simple examples that, like in the middle example is the regularly occupied spaces, and lower left would include things like the sight lines for IEQ C8 for daylighting and views. And those require that you then go into a spreadsheet and enter in this data, which is about the exact same data that would be required for a lot of other downstream uses. So a lot of this is standardizing our data so that we can apply it for downstream use without having to manually re-enter information. And you'll see on that right example that we actually calculated the area of direct line of sight vision, so that was using an area plan, and these are all calculated values. So I came up with some, quote, sustainability principles of data. I really like the idea of the reduce, reuse, recycle, and the idea that essentially we are trying to reduce the amount of duplicate entry of data, or any wasted effort, essentially. And there are numerous cases where, whether we are talking specifications or design analysis or structural analysis, a lot of downstream uses are having to manually enter in the same data and keep them synchronized, which is even more difficult through the life of changes and the project. Garbage in, garbage out. Unfortunately, this does not follow the sustainability principles, does not turn into compost, so it's still the same thing. If we get garbage in, we're going to get garbage out. So we need to really pay attention to accurately defining what needs to go in, how we can verify that when it comes out it's correct. There is also a greater emphasis on quality and verifiable results that we need to work on getting out of the mentality of, once things look right on the sheet, we're basically done. If we continue that process, we will not be able to really take advantage of some of these other efficiencies. And the other thing to highlight is that it's important that we have a solution that covers all of the information, even stuff that cannot be stored in the sheet. And so the next two slides are just, I'm not going to go through each of these, but I get the question frequently, why aren't we using BIM data already? And so we've started to collect some of the examples of things that have kind of caused things to be difficult, and I'll just highlight a few here that we really are switching from a process of construction document generation to information management. And things like plans and specs and DAs are one set of deliverables, and definitely the most important contract documents, but the models are the things that generate those and can also be utilized for downstream processes and affect our efficiencies significantly. I would also say that I'd highlight content management and QC on BIM data, because those are also recurring challenges, and also number 12 there, that trust is not implied. We have to have a verifiable process. So at this point, I'm going to hand it over to Logan, and he's going to show you some examples of the current and model-based processes.
So as Van said, my name's Logan Wallace. I'm a senior cost engineer in the Seattle district, and I'm going to walk you through some of the current workflows and contrast them a little bit against some potential BIM workflows that we're pursuing right now. So as a downstream user, a consumer of the BIM data, my job as a cost engineer is to take the quantities from a model or sheet drawing set that's provided and accurately determine all the quantities and then apply cost to them to determine an overall project cost. So when I first get a sheet set, one of the first things I would do would be to identify what do I need to take off. What exactly am I looking at? So on this picture, on the image in front of you, you can see I've highlighted a footing, a 6.0 footing. And the questions I ask myself as a cost engineer are, what makes up a 6.0 footing? What do I need to put into my cost estimate to determine the cost? You need to know the dimensions of the footing, how much reinforcement's in it, what's the strength of the concrete, how far below grade is it, and how do I get that in the current workflow on a 2D sheet? I would go to things like the footing schedule. That gives me the dimensions and the reinforcement. I would go to the detail sheet, which shows me how far below grade it is. And then thirdly, I would go to the construction notes or the specifications to determine what the concrete strength is. These are three separate places that I had to go to just to determine the makeup of one particular construction feature. So why can't we condense all of this information into one localized location within BIM? Here's that same footing pulled out of a BIM model, and you can see with one click, I can instantly see what the reinforcement is, how much, what size it is, the depth below grade. Problem is, as Van alluded to, trusting the model data. You can see right here in this particular instance, the thickness is reported as 18 inches. Comparing that against the actual drawing set where the thickness is reported as 16 inches. So this is an excerpt of a model that we haven't touched. This is without any modeling best practices in place. This is just the current state. So I couldn't reliably trust the information that was coming from this model. So the next step of being a cost engineer is actually, now that I know what I'm looking at, now I have to actually quantify it. So in this example, what you're looking at is an electrical drawing sheet. And let's just say I wanted to take off some of the lights on this one particular sheet. Here's a quick video I made up of what I would actually do in my day-to-day work of doing the quantity takeoffs for these lights. One by one, I go through and I click every single light that matches that particular light type. In this case, it's an RL1 light. So I'm not going to make you guys actually sit through this whole entire video and watch me click every single square there. Fast forward, there were 85 RL1 lights on one sheet. Now this is one sheet of a hangar project that had 58 electrical drawing sheets. So in theory, I would have to go through every single sheet, click all the RL1 lights for that one light type, just to determine how many there were. How can this be done in BIM? Well, here's a quick video of me doing it in the model. First, I select all of the RL1 lights. I group them all together. I say take off to RL1. Everything processes, and in approximately 15 seconds, I determined that there were 439 RL1 lights present in this hangar. It took me over 2 minutes to do 89 lights on one sheet, and that was me being prepared to do a recording, being familiar with the sheet, everything I was going to do, and in 15 seconds, we accomplished the entire hangar. Granted, this also revolves around me being able to trust that these RL1 lights are in fact RL1 lights and they should be where they are. So the next step of our quantity takeoff aspects is being able to visualize the data. So a big question we get a lot is, well, why can't the designers just spit out a big Excel sheet or a database from the BIM model and just give you an Excel spreadsheet that said there were 439 RL1 lights? So that's a good question, and we get that a lot. The question is, you need to be able as an estimator to understand what you're reading. An RL1 light is an RL1 light, but the construction that goes into it is not the same. If you're putting an RL1 light in the 50-foot bay of the hangar, that's a lot different construction methodology than when you're putting it inside a recessed ceiling in a 12-foot high office. So here's a quick video I made of some of the visualization aspects that Navisworks is bringing to the table. So going back to our footing example, we can tie this one footing from the model, I can link it to the sheets that are coming out of the model. So I can say, where else is this item located? Foundation plan, zone A. This is the 2D sheet that we're contractually obligated to. So Navisworks and Revit are giving you the ability to dynamically do your takeoffs between the sheets and the model at the same time. So I can instantly go and I can look at the detail of this. I can go back to the model. I can do my actual takeoffs. So let's see what that looks like in practice. This is a 2D sheet from the hangar. Let's just take off all of the footings from the model. After you take out the footings from the model, you can then dynamically update the sheet to reflect the takeoffs that you've done. This is the sheet with all the takeoffs, all the footings taken off. And let's just hide all the annotations and the markups. This is the same 2D sheet, and now visually I can look at the contractually obligated sheet, and I can see that from the model, I have taken off all of the reinforced foundations. But there's still a few things left, and those things are just the walls, and if we'd gone through the wall takeoffs, this sheet would be virtually blank right now. This is just another aspect that Van touched on of QA/QC. I can now do all of my takeoffs in the model environment, but still verify that I captured everything in the contractually obligated 2D sheets. So we've done all of our takeoffs. We have all the quantities. The next step is, what are you actually doing with them? And this kind of touches on why can't we just get a data dump straight out of BIM. On the left side of your screen, you'll see that this is the quantity takeoff catalog that comes out of Navisworks. This catalog is user-generated. I can make it look however I want. On the right side of the screen, you have the work breakdown structure from M2. This structure I can't alter. This is mandated by regulations. What doing our takeoffs in BIM is allowing us to do, though, is to create a mirror between the two, which ties them together. So now I can have a matching catalog in Navisworks that matches the structure that I have in my M2, which allows a faster QA/QC process. Now a reviewer can go down, have the Navisworks open on one side, the M2 open on the other side, and sequentially go through and make sure that all the quantities are where they should be and they match. Moving along with the QA/QC process. This is a drawing from an architectural takeoff that I did. When I'm all done with my estimate, I wrap it all up, I submit it to my boss for review. What I give him is my M2 file that has all my cost and estimating data, and I give him my takeoffs that show him where I actually derived all the quantities from. What my boss has to do now is look at a sheet just like this and basically determine if I made any mistakes. Now you look at this jumble of colors and lines, and granted, there's some tips and tricks you learn from doing this for a while to make the review a little bit more streamlined, but this is still just a visual review process. Somebody has to visually look at this and try and determine if maybe those teal colors should be, maybe those should be red, maybe that's a different door type, maybe the floors were taken off wrong. This is very difficult to digest as a reviewer. BIM gives us a lot of additional tools that allow a reviewer to quickly QA and QC a model, and this is all assuming that modeling best practices are in place and we can trust the data coming out of the model. Right here in this example, you can see I selected all of the walls that are type CB. You can see there are 152 of them. I can get the area quickly and immediately, and I can do this for any construction feature that's in the model. Walls, windows, lights, door types, pipes, you name it. And very quickly and accurately, I can determine that, as a reviewer, that the estimator is using the accurate quantity. And this allows me to focus more of my time and energy on ensuring that he's developing accurate costs rather than trying to make sure that he is developing accurate quantities. So back to our example now. Van touched on it briefly. We're never going to model 100% of a building. There's things that are below the minimum modeling matrix. Things like 1.5-inch pipe and just other features. You can see on this sheet, we took off all of the footings and the wall foundations. The walls are left, but we have this little hashed mark area here. And what this represents is this is depressed slabs in the sheet. These were actually put on the drawing sheet as a texture. This is not a modeling object. But let's just say we still need to take it off. We still have the 2D tools available within the workflows to add these takeoffs to our 3D quantity takeoffs. So what we're proposing isn't completely eliminating 2D takeoffs. Those will still be there for things like this example where it's just not going to be in the model. What we're working on is an integrated solution to really have a BIM-centric takeoff solution with just 2D supplementing it where needed. So another piece of the puzzle is iterations. Typically, for a standard Milcon project, we might do an estimate at 35, 65, 95, 100%, and then at the IGE phase. So when you do all of your takeoffs at a 35% estimate, and then the new iteration comes out at 65 or 95, what are we asking an estimator to do? Does he have to now recreate the wheel and do all of the takeoffs again and repeat all of that work? Typically, here's a workflow right here. This is a site work for a 65% drawing. I did all my takeoffs, and now the 95% comes in. So the first thing I would do in my standard current workflow is I would overlay the 95% drawings. Now you can see the designers shifted the sites a little bit. So now I'll align my drawings. And now as a cost estimator, I will visually look at this and I will try and determine if anything changed between the 65 and the 95. So it looks like everything's still in the same place. We still have the roads, the parking lot, the hangar aprons. But if you look really closely here, this blue line is the actual construction boundary. It used to be this red line way out here. So now if I wasn't immediately familiar with what happened in this project, I might not catch that the project is now not including this road, this parking lot, and all this concrete right here. And that's a really easy thing to miss. It looks like everything is okay, but this one line could drastically affect your project cost. So how does BIM solve that problem? BIM just has the tools innately to do the change analysis and measure the deltas between one iteration and another. You can visually look at these and you can see that skylights were added. You can see that this little overhang was added. Within 3 clicks, I can have it run a change analysis, and it can show me that these items right here have been deleted from the model. This quantity has changed. So very quickly and very accurately, I can measure and I can report to my PMs and update my costs that, hey, the 65% to the 95%, the costs have increased 20%, and here's what changed, and here's why. So let me turn it back over to Dan and talk about the work that we're doing now and what's next.
All right, thanks, Logan. So what we're going to be talking about now is an initiative that is being funded by headquarters. So Scott Wick has funded an effort to look at producing production-ready material for all disciplines. And Ray Lynn from Huntsville headquarters Cost Center of Expertise has also been funding this effort for a long time with Karen, and I believe both of you guys are on the call, so really appreciate that continued support for that. And Jason Fairchild is also participating in shaping this effort as well, and he's our BIM Community of Practice lead. And I think this is an interesting initiative because this is the first time I'm aware of that we're really bringing together design and cost engineering and BIM together to really figure out this problem. And it's really a balancing act between those three. So BIM will not be defining what cost engineers will be receiving, and it's really a balancing act to see what is needed and what's feasible. What we do absolutely need are, and these are the 3 major categories of what are being looked at, are repeatable processes, a specification of the data, and some form of content management. So this slide speaks to the repeatable and verifiable processes. The project execution plan and the minimum modeling matrix are already current USACE requirements by ECB 2013-22 and 2012-18. And I think if you're not familiar with those already, I would recommend that you go take a look at the CAD BIM Center BIM contract requirements, and that link is down at the bottom. The project execution plan is a project-specific description of what will be accomplished, or what the means and methods are that are going to be followed in a specific project, how the models will be organized, what will be in and out of scope, and essentially also defining the goals for the project. So this is where the cost engineer would need to be involved at the very beginning to ensure that the design team is aware that this, in fact, is going to be used for downstream quantification, and that review processes incorporate cost engineers being able to look at some of the early products even before submittal to ensure that both parties are on the same page. And the processes that we are looking at are going through each discipline and identifying the best practices that would be required for all three. So this process starts with Logan and the cost engineering group defining estimating requirements. What types of parameters would be needed in order for them to perform an estimate? And this is not really requiring that cost engineers perform estimates a particular way. It's just essentially giving us a target from the BIM perspective that has a high level of confidence from the cost estimating community of practice that if we were to provide this information, they would be able to perform an estimate. And essentially from the estimating requirements, we will then be analyzing the modeling best practices, quantity takeoff best practices, and estimating best practices that would be required to consistently and accurately produce those results. So the second aspect that I mentioned after repeatable processes is the data specification and verification. So what you're looking at here are, on the BIM side, what two of the large activities are that we are undergoing. We have started with the structural discipline, and if you look in the upper right-hand corner, there's the USACE minimum modeling matrix, which is organized by OmniClass and Uniformat. And we're going down to level 4 and 5 to identify each and every item that we would consider to be structural in nature. For each of those, we are identifying a data sheet and a verification sheet, or sheets, one or more. The data sheet really indicates the parameters that would be required and how they would be derived, as well as demonstrating them live in the sheet that you're looking at here. So this is actually a view that has callouts to those actual parameter values. It not only provides a way for us to define the parameters that are required, but it also gives BIM users the ability, as when we publish this, they will be able to go look at the model files to see how this worked and what exact parameters were entered in order for the values to come out correctly. It also gives us the opportunity to check these assumptions and these specifications from version to version. So when we move from 2012 to 2015, for example, we can run this data sheet through that process, and if we don't get the same results as we did in 2012, then we definitely would need to adjust our best practices. Now, the verification sheet on the right side illustrates, I think it's a commonly known issue, but it sort of illustrates how we're going about documenting this process. So I think a lot of folks already know that in Revit, if you are following a continuous wall as a host and you're placing a wall foundation along that, it will accurately reflect calculations of volume and length when voids are intersecting in between, and that's what you're seeing in that middle section there. But it does not accurately subtract from the length the intersections of other wall foundations that intersect it. And so essentially we're going through and looking at how each of these objects behave to verify that just because it says length and it's a calculated value, let's ensure that in some of these cases that it's actually reporting accurately. And then from that we give ways to allow a user to derive values if there are particular workarounds. So in this case, volume comes out correctly and we have width and height, so length can be derived. And this is just an example of the type of process we're going through on an object-by-object basis. And I guess I would emphasize, having now worked with the cost engineers for a while, that it's, I think we're probably repeating this enough times, but it seems to me pretty consistent that something that is 100% verifiable and that we have a high level of confidence on the BIM side that we can deliver is much more valuable than having more information that is less verifiable. So at this stage, we're really trying to make sure that whatever is specified, we have a very high level of confidence will be delivered on a consistent basis. And then we intend to continue to improve our processes over time. So this page also shows some additional examples of verification, but it essentially still follows the same idea. So for example, on the right side, we're showing compressive strength as a material being assigned. Oh, I'm sorry, this is actually model reinforcement, estimated reinforcement being applied, and if that value is not provided, it will highlight red just to illustrate to the designer how these things work. So these are meant to go through each item and also serve as an example of how to do it correctly while modeling. And the next part is content and content management. So we, in our reduce, reuse, recycle kind of analogy, reusable content in the form of templates or in the form of prior projects, it's really important that we try to make sure that the most common workflow of taking something and placing it into a project results in the highest degree of potential success. And there are new templates and workspace content coming out over the course of time, and we want to make sure that these things reflect the requirements that are being identified and verified. And we're also looking at methods for enterprise-wide BIM content management, where instead of a template carrying all the potential families, you're looking at an example here of a tool called Content Studio that might be able to assist with the process of something going from being a reference library, like a delivered Autodesk out-of-the-box library, being then copied to a particular project, and kind of going through this process of being able to differentiate user-specific content on their local PC versus project-specific content versus district and then reference content, and just really trying to not prevent any of these from happening because these are necessary operations for the efficiency of a project. We want to encourage content evolving and developing, but we also want to be able to have it be accountable and be able to identify what something actually particularly represents. Has this been checked, and do we believe that when we reach a particular submittal stage that we have verified all of the content that's there? So finally, where do you go to get started? for those of you that are interested, what you're looking at the right side is documentation from a pilot project that was completed for Raylin, and we essentially went through and identified existing state of a project and an initial pass, I would say, at the estimating requirements, and also identifying things where we would not necessarily get that data from the model, we would get it from the drawings. So this was a comprehensive list that the cost engineer identified for performing an estimate. And this round now of the effort is going back and looking at these requirements and seeing if there are ways that we can provide them, let's say, rather than them having to be calculated or derived from the drawings, whether we could include them in the model in a consistent way. So the BIM COP SharePoint site at this following address has a section under the shared documents quantity takeoff folder that has a report where we publish some of our initial findings. And that's free for those on the call to go ahead and check out, and we're happy to answer any questions from that if any arise. But we'd also like to have you contribute sample models, templates, and submit questions and concerns and suggestions.
Thank you, Van. Thank you, Logan.
Really
I am going to go ahead and start with the questions. We've had one come in so far, but while I'm waiting for maybe a couple more to come in, I'm going to go ahead and go over some of the links and files that you see on the screen there. At the bottom right-hand corner in the file share window, this presentation can be downloaded. You can save it to your computer, so you just have to click on the file there, and it'll download to your computer. And then above that, we have the web links there. So one of them is to our past webinar videos. The other one is the Sustainability Energy website, previously called the MRSI site. And then you can also email us at s_ewebinar@usace.army.mil if you have any questions or comments. So the first question that we've got here is, when AEs are providing these quantities, is there a way for them to provide the quantities by sheet or by area? Is it more efficient if a cost engineer can do a QA verification on part of the total quantity in lieu of the total quantity?
Kim, can you hear us? We're trying to transition from using our headphones here.
Yeah, I can hear you just fine.
Okay, could you repeat the question again, please?
Sure. It says, when AEs are providing these quantities, is there a way for them to provide the quantities by sheet or by area? Is it more efficient if a cost engineer can do a QA verification on part of the total quantity in lieu of the total quantity?
So if I received hypothetically a just total quantity spreadsheet from an AE, that's not particularly useful for me aside from maybe a reality check for my own takeoffs. Like, I couldn't receive something from an AE that just said, hey, you have 500 RL1 lights. Because this goes back to the trust issue. I can't, in the end, if I turned in an estimate and it turned out that was wrong, I can't just point my finger and say like, oh, well, the AE told me it was 500 when it was actually 700. So just receiving quantities from someone, I have to go in and validate those myself. So that's why we're really working on these modeling best practices. And even once these modeling best practices are in place internally within the core, it's not like I can just run a magic wand on BIM and have it spit out all the quantities to me, because that's why the visualization aspect is so important to this process. Is I need to be able to, I'm responsible as a cost engineer to validate that those quantities are in fact correct. So that's one of the biggest questions we get is, well, why can't you just receive a big data dump out of BIM with all the quantities already in it? Why can't you just use schedules? And it's because I can't just go on faith that the numbers you give me in a spreadsheet are accurate. I have to visually verify that these represent what are in the plans and specifications. Does that answer the question?
Yeah, that was great. Thank you. And that's the only question that we've gotten in so far. So again, if anyone has any other questions, go ahead and type them in, and I'll read them off for Logan and Dan to answer there. Dan or Logan, do you guys have any follow-up comments you'd like to make?
Maybe just to add to Logan's last comment, I think the other thing to recognize is that we can't necessarily expect that cost engineers are BIM experts. They are not Revit or ACOSIM building designer authoring content kind of professionals that use modeling tools day in and day out. And this intermediate part approach with the quantity takeoff being a specific activity is really geared towards cost estimators and not necessarily modeling experts. So that's another reason why we can't just expect that when you are done with a project as a designer that we just either export all of the content and expect that they can go visualize it either in BIM or some other static method, but really these tools the quantity takeoff tools are very specific towards supporting those 7 kind of activities that we identified. So certainly the data is useful, not to say that there aren't different ways to get data out, but we're really trying to look for something that addresses all the activities and provides the highest level of confidence of data.
Okay, and we do have another question here. It's asking, is USACE leaning towards standard software such as Revit, Autodesk QTO, Navisworks, etc.? And I guess to take that one step further, does this quantity takeoff, does it work just in Revit, or would it also work in other software programs?
Yeah, that's a great question. So essentially, that's a question for headquarters in terms of standard software. What they have said to date is that the tools that we should use are based on what our customer wants delivered. And our customers have indicated wanting Revit and ACOSIM Building Designer, depending on who the customer is. So I would say no, I don't know that we are planning on standardizing. I have not heard any kind of suggestions toward that effect, but there has been a lot of movement towards Revit, and I think over the last 3 years, we just had a BIM community of practice meeting last month, and there were some quick surveys showing that at least half the districts are now using it. So there's a lot of activity there. In terms of Autodesk QTO, that product is no longer in development, so I don't think anybody will be standardizing around that. But the features in Autodesk QTO, which is what we did the pilot project on, have been rolled into Navisworks and are being continued development in the Navisworks platform. It is still kind of in the early development stages in terms of Navisworks, so we're expecting that a lot of additional features will still be added past this version 1. And Navisworks itself takes input from dozens of file formats. So the intent is that we can receive input from ACOSIM Building Designer or ArchiCAD or Revit or what have you. What doesn't change throughout all of this is what a cost engineer needs to have in order to perform an estimate, and that kind of gives us the starting point for taking a cost estimating tool, a quantity takeoff tool to produce those results. We are focusing on Navis just for this particular effort because it satisfies the largest number of goals that we're trying to achieve. But that's not to say that at some point in the future there'd be some better tool that allows kind of a sheet-based 2D, 3D integrated workflow. So hopefully that answers the question.
Great, thank you. And we do have a few more questions coming in. The next one asks, other than structural, what other functional areas will you focus on next for quantity takeoff?
So we haven't formalized the schedule yet on this, but we have looked at the sequence of events that we're going to be taking the structural discipline methodology and working with the COS BIM managers to pick 3 to 5 disciplines per fiscal year. And we're really planning on targeting MEP as our next series of disciplines. But those are still all kind of open to determination based on availability of COS districts and how things shake out after this fun end of fiscal year and when we turn around and start to look forward. So I'd say we have some plans, but they haven't been finalized as of yet.
Yeah, I mean that kind of it depends on what you get out of it, but that really touches on the visualization aspect, and I kind of breezed through it in my portion, but I tried to illustrate how Navisworks has integrated the model with the 2D sheets, which has become a very essential part of our future workflows for validating the quantities that are coming out. So when I look at a quantity takeoff, or a reviewer looks at a quantity takeoff and says, hey, there's a 200 linear foot beam in there, what does this represent? Very quickly they can click on it, they can look at it in the model, and then they can look at all the sheets that it's displayed on. So being able to reference a spreadsheet value and what that actually represents in the designer's intent on the sheets is critical, and it is difficult without the tools. That's why we're kind of following Navisworks right now, is because that kind of functionality, just we haven't found that in another tool, and it's critical to validating the quantities.
And I guess I would add that the ability to create a work breakdown structure to logically organize the BIM objects in a particular hierarchy that is relevant for a project allows that cross-reference directly with the estimate too, because I would think in most cases the work breakdown structure that you're using to organize elements in the quantity takeoff would match up with the line items in the estimate. And so there should be a direct connection, or maybe the better way of saying it is we do not want to lose the connection from where something was created to where it was taken off, and then where it was estimated, that you should be able to go back and validate where something came from.
Yeah, and to add on to that, I just thought of a great example that we've actually run into before is if you, I've received quantity printouts before for things like plumbing, and it'll have 2-inch pipe, say 500 linear feet. If I just looked at that on a spreadsheet, sure, that's 2-inch pipe, but is that 2-inch pipe part of the cold water potable water plumbing system, or is that part of the fire protection system? Does it go to the sprinkler heads? And that's critical for actually where you're placing your cost and your estimate,
Okay,
because
we have
if
one
you
more
have a cost
question
overrun,
so far.
we might want to know that
And
the
it
fire
says,
protection
how
system
can other
is
district
150% what we
cost
thought it
engineering
would be.
sections
So
participate
a
or
2-inch
get
pipe
involved?
on a spreadsheet is just a 2-inch pipe. That's where the cost estimator comes in, is being able to determine what that pipe actually represents. And if you just have a spreadsheet, you don't have that ability.
So Kim, could you, actually I probably have access here. Let's see. This is what I would suggest in terms of getting started. Um, the pilot project that we completed at Seattle District was a pretty 80-page thorough documentation. It may be a little more than you want to read, but it will give you, specifically in section 3 or chapter 3, it'll give you some background in terms of how we would expect to be taking off this information and where the information would be coming from and what type of information would be needed. So I think there's a lot of information that could be kind of absorbed there. But again, I would also suggest that feel free to reach out to us. We would like to receive sample models, but that's more, I think, to help our development process. If you are interested in getting started, we're more than happy to talk with you and to kind of walk you through what we've done up until this point. We will also need some review and critiques of structural disciplines and the other disciplines as they come on board. The other idea at this point also is if any of the cost engineering sections are currently using products like on-screen Takeoff, which Logan was, a lot of his examples were illustrating on-screen Takeoff type workflows. You can start looking at Navisworks 2D workflows without having to do anything in terms of changing your BIM aspects of the workflow. So in other words, it may help serve as a transition into a 3D and model-based workflow to just simply get started performing 2D takeoffs in the platform that will eventually allow you to get some of this other data. And that, there might be cases where some of the content is already very regularized and something that you could already start doing some sort of hybrid 2D, 3D takeoff process. So I guess those would be my suggestions. Logan, do you have any other ideas as far as how to get started?
As Van said, I guess for cost engineering specifically, I think the biggest way to jump in if they wanted to contribute would be to look at the report. As Van said, in chapter 3, I outlined basically the start of estimating requirements for construction features. So that was reviewed internally in the Seattle district. It would kind of be one of those things, if somebody thinks that we missed something or had something to add to those estimating requirements, I mean, definitely reach out and contact us. I mean, nothing we're doing right now is written in stone. It's supposed to be an iterative process. So
right,
if
well,
I
that was
didn't
the
list
last
reinforcement
question we've
for a slab on grade,
got, for today.
that's a
So I
big
just wanna
oversight. So
say
I
a
think the
quick
biggest
thank
thing
you
if
to Dan
someone
and
in cost
Logan
engineering
for a
wanted to
great
be involved
presentation there.
would be
I'm going to go
step
ahead
one
and
would be
leave the webinar up for a little while longer so people can download the presentation file itself if they want to. Otherwise, just thank you to all the participants, and that's it for today.